It used to be engineers had to build a bunch of prototypes or different versions of their design in order to come up with a final product. But today we have these really powerful computers and digital tools to help us. And we will be using one of these digital tools in order to help us do both the design and simulation of our rocket so that you only have to build one rocket and it'll perform well. In this first part on digital design and simulation, we'll talk about the digital design. And the second part, we'll show you how to do the simulations. The program we'll be using for our digital design is called OpenRocket. Okay, well now that you understand the concepts of center of pressure and center of mass and how they affect stability, let's design a rocket that will be stable. To do that, we're going to be using our simulation software, OpenRocket. So navigate to the place where you downloaded that file and just double click on the OpenRocket file, and that will open up the program. And when you first open it, it'll look like this. Now we provided you a generic design file that has our basic rocket in it. And you should open that now. So if you go to File, Open, and then navigate to wherever you stored that file. I'm not sure where you stored it, and I'm not sure exactly what the name of it will be. This is the current version. Should be something like that, Rocketry Camp version something or other. And if you open up that file, you'll have a basic rocket here. Now this rocket isn't flyable the way it is right now. You're going to have to do some design work on it. But we put all the components in here to make it a little easier to run. And we'll just kind of go down from the top down and show you what pieces in here. So we have our nose cone, and this nose cone may not be the right length for yours. I'll show you how to adjust it in a minute. And then behind the nose cone is the body tube. Right. And then inside the body tube we have our motor mount, which is the whole motor mount that you've already built. You've built this physical motor mount. You know, there's the motor tube itself, and then there's the first and the second centering ring on the outside of the motor tube that connected to the body tube. And there's a centering ring on the inside that we use for a motor block, and then finally there's the engine hook there. So all that stuff together is the motor mount. Mounted on the outside of the body tube we have our launch lug there, and we have our fins, and I'll talk more about the fins in a minute. And inside we put our shock cord and our altimeter and our streamer. So those are all the main parts of the rocket and the main parts of the body. Now the first thing that you're going to have to do is make sure that the nose cone that we have in here is the size and shape of your nose cone. So you can either come down here and double click on nose cone, grab the nose cone and double click it, or you can come up to the menu here and double click on it there. And that should open up this panel that'll allow you to size the nose cone. There's basically three different kinds of nose cones, or three different shapes that you might have. You could have a conical nose cone, which is like this, which has straight sides on it. You could have an ogive nose cone, which is a nose cone that has a gradual curve, but it comes to a pointy end. Or you might have an ellipsoid, which is a nose cone that has kind of a rounded end. It's curved, but it has a rounded end. So these other styles in here, you might have one of those, but I would stick to these three. They're close enough to the kind that you have. If you just look at your nose cone and see whether it looks like a conical one, an ogive one, or an ellipsoid. And I know the nose cone that I'm using is an ogive. And the other thing you're going to have to adjust here is the nose cone length. And the nose cone length is not the whole length of the nose cone. It's the length of the nose cone from the tip down to where it runs into the body tube. This part down here is what we call the shoulder. And I know I measured mine, and it was 10 centimeters. So I'm going to change this to 10 centimeters. So that's the nose cone that I happen to be using on the rocket that I'm working on. You'll have to measure yours and adjust this length. Okay, now that I have my nose cone the proper size, the next thing I need to check before I can start doing my stability design is to make sure I have a motor installed in my rocket here for the simulation. And this gray part back here is the motor itself. And you should already have a motor installed in there. To double check that, click on this tab for motors and configurations, and you should have a configuration here that says you have a B64 motor. That's a B6 motor in terms of thrust with a 4-second delay. If for some reason you don't see this gray thing and then there's no motor in there, or if it's a different motor, you'll have to adjust that and put a new one in there. So I'm going to remove this for a minute just to show you how. So you might come in, open up your rocket, and there's no motor in there. If that's the case, click on Motor and Configurations, click on New Configurations, and then over here in this blue part that's highlighted, double click that, and that will open up this window that will allow you to accept the motors. The motor that we want to use is the Estes B6, and then you want to come here for the engine delay and check 4 and load that motor in. And now when you go back here, we're ready to start the actual stability simulation. I start the design process by looking at the stability of the current rocket design. Now here in the center of the rocket, you'll see the symbols for center of mass and center of pressure. And you can see right here that the center of pressure is behind the center of mass, which is good, but it's not very far behind. In fact, we're going to say that this is not sufficient stability for the rocket. And so we want to move the center of pressure back farther or the center of mass up more in order to separate these so we have more separation between the two and we get a more stable rocket. So the first question you need to get the answer to is, well, how far apart do these have to do to be stable? Well, we have a parameter over here called the stability factor. And if you see this right now, it says the stability of this rocket is 0.13 cal, whatever cal means. And cal doesn't mean calories in this case, it means caliber. And caliber is the diameter of the main body tube. And so what this 0.13 is telling you is that the center of pressure is 0.13 times the body tube diameter behind it in length. And that's too close. What we want is that for our rockets, we would like to have a stability factor of 1.5. So in other words, we would like the center of pressure to be 1.5 body diameters behind the center of mass. So this rocket is not stable enough for us, and we're going to have to work on the design to make it stable. In order to improve the stability of this rocket, I'm going to have to change some parameters in my design here. But I can't change everything here. In fact, there's a lot of things I can't change. I can't change the nose cone. We've given you a nose cone and you have the one you have, so that's not going to change. You can't change the diameter of the outside body tube because we gave you one that's only a certain size, and you can't change that. And your motor mount down here you've already built, and it fits inside the body tube and it holds the motor, so that's not going to change. And none of this stuff on the inside of the rocket is going to change because you need all that. So what can we change? Well, there are two big pieces of the rocket we can change. One is the length of the main body tube, and the other one is the shape, size, and number of fins. So those are the main two variables we have to play with, the body tube length and the fins. Let's start with the body tube length. So I'm going to double click here on the body tube, or you can go up to the menu and pull down body tube, and we'll get this little menu here that allows us to change the body tube. Now the only thing that you can change in this body tube is the length right here. The diameter and the wall thickness, the inside diameter, that's all set because it's the body tube that we already gave you to work with. But you can change the length of it because you can make it shorter or longer. You can't make it longer than the piece we gave you, but you can make it up to that long. And if I grab this little slider here and slide it back and forth, that changes the length of the body tube. So we started off with a body tube of 20 centimeters here. Now I'm going to increase the length of the body tube. Let me slide this down closer here. Increase the length of the body tube, and I want you to see what happens to the center of mass and center of pressure as I increase the body tube. So as I increase the body tube, notice that the center of pressure and center of mass get farther and farther apart. And I can increase it either by sliding the slider or by clicking the up and down buttons or by typing in a number. And those increase the separation between the center of pressure and the center of mass. Now, it's going to be really hard for me to get a stability factor of 1.5 here by increasing this. In order to get to a stability factor of 1.5, I'd have to make this thing 39, looks like 39 centimeters long. And then, you know, I don't want a long, skinny rocket. I'd like a shorter rocket. So I'm going to make this a little smaller. I'm going to come down here to say to try and get this, I don't know, I say like 32 centimeters looks kind of nice, and it gives me a stability factor of 1. So I've increased my stability factor of 1. So I'm going to select that for my body tube. So I've increased the length of the body tube. Notice there's a lot more separation between the center of mass and center of pressure, but I'm still not quite up to that target of 1.5 that I want. So now the other thing that I have to change now, it will be the fins. And that's what we'll do next. Okay, well now I'm going to change the fins to get that additional stability factor that I need, so I can get the stability factor up to 1.5. And I can do that either by double clicking on the fins themselves, or I can come up here to the menu and double click on fin form. And I'm going to get this menu right here. And this menu allows me to adjust the fins. There's two tabs in this menu we'll use. The first one allows us to change the number of fins. And that we can either have 3, 4. You can have more than 4 fins, but I recommend sticking to either 3 or 4 fins. If you get more than 4 fins, it gets hard to glue them onto the body, plus you got to cut out that many more fins. And notice, right now we had 3 fins on the rocket, and the stability factor was just right about 1. And if I go to 4 fins, notice already that the stability factor jumps up to 1.76. See how far apart my center of mass and center of pressure are now? So at 3 fins, they're at these locations, and at 4 fins, they get a whole lot farther apart. But you know, I don't want to do 4 fins. I don't want to cut out the extra fin, and besides, I think 3 fin rockets look pretty cool. So I'm going to stick with 3 fins, which means I'm going to have to change the shape of these fins in order to make the rocket stable. So I'm going to click on shape, and I'm going to get this little tool here where I can just move these points around to change the fins. And these are very simple trapezoidal fins right now, and they just have these 4 points in them. And you can grab any one of these points and move it around. And notice how quickly changing the fins changes the stability factor, way faster than when you just change the length of the body tube. They move the center of pressure back quickly. And you can do all kinds of different shapes of fins. You can do some cool shapes like this. You can do swept back fins that go back behind the rocket. You can do kind of fat fins. You can do skinny fins. You can even add in an extra point, and then you can do a fin that looks something like that, sort of like a airplane fin. So there's a lot of things you can do. I think I'd like to do a fin that's kind of swept back and has a square tail to it like this. And then I think I'm going to kind of do a thing like this. I think that's the kind of fin shape I'd like. I think that looks pretty cool. But notice now I've actually decreased the stability of my rocket here. It went down from 1 to 0.67. So I've got to increase the size of these fins. So that's what I'm going to do now. I'm just going to make them a little bigger, make them go back a little farther. That doesn't quite do it for me, so let me make them even a little bigger. Ooh, notice how fast that changes them. So that looks pretty cool right there. I'm just going to do this to change the shape of them, and now I kind of like that shape of them. So I think I'll do this. Maybe I can make this a little skinnier at the back. And there, that looks pretty good to me. So I kind of like that shape of fins. Now, another thing I'll do when I'm done is I have all these weird numbers up here, and it's going to be hard to measure. So when I'm done with it, I come and I like to round these all to even or close to common centimeter numbers so that they're easier to measure. So that one's 3. I'll make this one 1.7. Make this one 5.8. Make this one 2.4. Maybe 2.3. Make this one. Just gonna make this one 1. And make this one maybe instead of 5. I need to have these two the same, so they're 5.8. Okay, so there's my fin design, and I know the location of each one of these points, and that's important because you're going to have to take this picture and lay it out on a piece of cardboard and cut this template out. And so these are the dimensions in centimeters for your fin. And I have a stability factor now at 1.58, so I'm good with that, and I can close that. And you can see I got my 3 fins here. Now you can't quite see all 3 fins, but if I go back here from side view to back view, I can look in here and say there's my 3 fins. Here's my motor. Here's the outside body tube. This is the launch lug, that other circular thing you see on there. And so now I have a rocket that's stable, and the design looks good. So I'm going to save this design now, and then I'm going to go on and run the simulations and show you how to do the simulations to double check the stability. And that's what we'll do in the next video. So make sure you save this file, I'm going to save mine under a new name. I'm going to call it Rocket Camp. Put my initials in there, WAK, and save that file. So now you open up your rocket file, you play around with the fins and the length of the body tube. You can make some really cool fin designs. Don't get them too complicated because you got to cut them out by hand. And when you've got done and you've got a stability factor that's at least 1.5, save your design, and then in the next video I'll show you how to run the simulations.
Try to make a man.